Hi everyone, we're going to start Module 5 today. And what we're going to do in Module 4, we focused a lot on graphing linear functions. In Module 5, we're going to kind of flip that question. So instead of me giving you an equation and asking you to graph it, I'm either going to give you a graph or maybe some information about a graph, and you're going to use that to write the equation. So for 5.1, we'll start with equations in slope-intercept form, which is something we learned in Module 4. And slope-intercept form is this right here. It's y equals mx plus b. That's a real important equation you want to remember. You're going to use it a lot over the next few years. And the reason we call it slope-intercept form is because you get the slope and the y-intercept right from the equation. So whatever number you see here in front of x, that's the slope, m. And whatever number is being added or possibly subtracted off the end is the y-intercept, positive or negative. So if we're going to work this question backwards, the first thing you always want is the slope. The slope comes first. You can't write the equation of a line without knowing what the slope is, so you always want to find that first. The second part, b, there's kind of ways to work around that, but not slope. You got to know the slope to write the equation. And this is what I meant by working around it. If you don't know the y-intercept, you can actually find it using any other point on the line as long as you do know the slope. Remember, slope has to be first. So I said if you know the slope, that's m. If I give you a point on the line, remember every point counts for an x and a y. There's two values in there. So if you put in your number for m for slope, you put in your x, you put in your y, what you have is an equation that you can pretty easily solve for b, which is the y-intercept. So let's try that out. We're going to write the equation for a line with a slope of -3 that goes through the point -2, 1. This is the exact situation I just described to you. I said we need to know the slope, and we do. This time I just told you in the equation, or in the directions. The slope is -3, that's m. Now we don't know the y-intercept, but what I did give you is a point, and every point counts as an x and a y. So let's start with what we have. Our slope-intercept form is y equals mx plus b. And I said you always want to find the slope first. This was as easy as can be. I just told you what it was. It's -3. So let's put that in. We have y equals -3x plus b. Now, if you knew what the y-intercept was, like let's say I told you the y-intercept is 10, just put a 10 in and you're done. But see, we don't know that. So what I'm going to do instead is I'm going to take my x and y, the x, the -2, I'm going to substitute right here for x. The y, which is 1, I'm going to substitute right here for y. And let's see what that turns into. So I'm going to substitute 1 for y, leave the -3. Now, -3x means -3 times x, and x is -2. That's what I'm substituting for my point. And then you still have that plus b on the end. So this is the equation that you want to solve for b. You can usually do it in 2 steps. Leave the 1, multiply, -3 times -2 is +6. And then to finish solving for b, I just want to get rid of that +6. So I'll do it by subtracting 6 on both sides. 1 minus 6 is -5, and we just solve for b. So what we actually did, we found the y-intercept. When you find b, you found the y-intercept. But what's more important is if you take that number that you just found for b, and you put it in for b right here, that's the answer to the question. So my final equation is y equals -3x. Now instead of plus b, I just found out b is -5. So I'm going to put -5. And that's the answer to the question. That's the equation of the line. So what we really needed was slope and y-intercept. I gave you the slope. We just put that in. The y-intercept, we had to do a little work for. We had to plug in numbers for x and y and solve for b. All right, let's do a second example that's actually kind of simple. Write an equation for a line again. This time I didn't give you the slope. I gave you 2 points. I said it goes through the point 6, -1, and also -2, 3. So you think back to Module 4 and you remember, okay, I remember when he gave me 2 points, I can use the slope formula to find the slope. And the slope formula says m, the slope is y2 minus y1 over x2 minus x1. And then you look at your points and you say, okay, well, let's label them. Now remember, each point is always x comma y, x first and y second. But when you have more than one, you number them. So I'll call this one x1, y1, and I'll call this one x2, y2. Oops, make that a y. x2, y2. And remember in Module 4, we said it doesn't really matter which one is which. If you called the first point, the 6, -1, x2 and y2, and the other one x1, y1, it'll still work out. Just pick one and call it x1, y1, and call the other x2, y2. So let's go back to our slope formula here and put the numbers in. y2, if I look up at my points there, y2 is 3, minus y1, which is -1. And on the bottom, x2 is -2, minus x1, which is 6. So on the top, 3 minus -1. Minus a negative becomes plus a positive. 3 plus 1 is 4. And on the bottom, -2 minus 6 more would be -8. So my final slope is definitely going to be a negative number because it's positive divided by negative. 4 divided by 8 doesn't go evenly, but it does reduce nicely. It reduces to 1/2. If you divide both of those numbers by 4, the slope is -1/2. So now what we have is basically the same example we just did. We now have the slope, m. We have 2 points. You can actually pick either one. It doesn't matter which one you choose. I'll go ahead and use the first one. And I'm going to do this exact same thing we did in our first example. I'm going to use y equals mx plus b. And I'm going to put the new slope in that I just found, which was -1/2. And I'm going to say, okay, well, I still don't know the y-intercept here, but I can find it by plugging in x and y. Now, I can use either point. I don't have to call them x1, y1, x2, y2 anymore because I'm only using one of them. But pick either one, and I'll do the one I circled. Plug in -1 for y. Plug in 6 for x. And then solve for b. So -1 will leave. -1/2 times 6 is -3. Positive times negative is negative, and 1/2 of 6 is 3, plus b. Now I need to get rid of that -3, so I will add 3 to both sides. And what we end up with is b equals 2. Put that here just like before, and there's your final answer. So final answer to the question is y equals -1/2 x. And that was a positive 2, so I'll put plus 2. So that was a little harder. We needed the slope and the y-intercept, and I didn't give you either of them in the question. If I give you either one of them, just put that number in. Super easy. If not, you have to find a way to find them. And we use slope formula to find the slope, and then we used our same trick from the first example. We plugged in 2 numbers from a point and solved for b. All right, the last part of this lesson is to actually look at a graph. Let's say instead of me saying, okay, the line goes through these 2 points, or it goes through this point and has this slope, if I just say, here's a line, and I show you a graph, this is what you're going to do. Number 1, we always want slope first, and the easiest way to get slope from a graph is rise over run. So find 2 points on that graph, do your rise over run, figure out what the slope is. Now, number 2, we need the y-intercept. Sometimes this is very simple. Not always, but sometimes. And I said usually you can just tell by looking at it. So if I'm looking at my graph, let me draw a little example here. Let's say I'm looking at a graph and it kind of goes like this. And I can tell it crosses the y-axis right there at 2. And I go, okay, the y-intercept is 2. And I just use 2 for b. So if you can tell the y-intercept by just looking at where it crosses the y-axis, definitely do that. If you can't tell, so let's say maybe you have a graph that looks kind of like this. And you're like, well, I don't know where that crosses the y-axis. It's way down, it's way down off my screen. You know, I can't see that. Then what you can do is pick a point on the line, maybe this is the point 4, 2 or something, and use the same trick that we just did on the last example. Plug in x, plug in y, plug in the slope, and find it that way. Solve for b. And this is what it says right here, even though my graphs are covering it up a little bit. It says if you can't tell just by looking at it, pick a point on the line. substitute x and y, solve for b, just like we did before. So let's do one last example for today. We're going to write an equation for this line right here. Now, the first thing I'm going to do, now, normally I say let's always do slope first, but on this, I'm just going to check and see if I can tell what the y-intercept is, and I think I can. It's this point right here. So with almost no work at all, I can tell that the y-intercept, b, is positive 4. And we're counting by 2's on both the x and y axis here. Now for the rest of it, I need the slope. So let's do rise over run. Now I already have 1 point. You need 2 points to do rise over run. I'm going to go ahead and use the y-intercept because I already marked it. You can pick any other point that you can clearly tell is on the graph. So for me, another really good point would be the x-intercept. I would probably use this one right here. But that doesn't mean you have to, because like for example, this point right here is also on the graph. I could use that for rise over run, the point 2, 8. Or maybe down here, this point right here looks like it's exactly on the graph, -6, -8. So anywhere where there's a point right where the x and y, where they're both like perfect even whole numbers, that's good to use for rise over run. But I'm going to go ahead and use the x and y intercept because those were the two most obvious to me. So if I'm doing rise over run from the x-intercept, it goes up 4 and then right 2. So for rise over run, up is positive, so I'll do positive 4 for rise, and to the right is also positive. So the slope is positive 4 over positive 2, and 4 divided by 2 is 2. Now see, there's no extra work. You have the slope, you have b. I don't need to solve for b, I already know what it is. So when I go to y equals mx plus b, I'm just going to put in the slope for m, which was 2, put in the y-intercept b for b, which was positive 4, and that's my final answer. So a lot of times, especially the ones where you can tell the y-intercept just by looking at it, writing an equation for a graph is actually easier than our first two examples for today. It's easier to do that than to try to write the equation when I just tell you a little bit. If I say, okay, it goes through these 2 points. Or even the first example, when I told you the slope, you still had to do work to find b. It's always a little easier if you can tell b just by looking.